So the topic is, as you can see here, it's machine learning with the TensorFlow. Actually, there's no reason that we gonna use a TensorFlow for the machine learnings, but here I'm focusing on the TensorFlow because we're gonna use a TensorFlow a lot for deep learnings. So here I'm gonna explain how to use or what's the main structures for TensorFlow, just using some of the examples that we learned in the machine learning. So as you might know, here in order to train the neural net, there are many different libraries for deep learnings, and probably one of the most famous one is TensorFlow and the Keras and PyTorch. And let me see. I mean, this one is basically, this one is much easier to use, but I believe that when we learned the deep learning flow, probably if you know if you know the TensorFlow and to see how you can program it, probably you guys can easily understand and make use of Keras or PyTorch by yourself. So that's the reason that I decided to use a TensorFlow. And for Keras is now TensorFlow 2.0. Basically, these are pretty much the same, but here I will say 1.0. So there will be most of the things that I'm gonna use in this class or lectures. And let me explain some of the key things related to TensorFlow. It's developed by Google, and one of the most popular machine learnings, or I would say deep learnings libraries. Is perform the computations very efficiently and is gonna use a GPU to even speed up even further. And one of the reasons is that it's one of the widely used libraries in a lot of communities and the examples on internet. So that's why we're going to use it and implement it in machine learning and deep learnings. Involve large number of mathematical operations and large number of communities. And let me explain some of why the name is Tensor and Flow. Gets name from tensors, and tensor is basically, if you know this, so it's array of arbitrary dimensions. Say we have this, you don't have to understand it, but these are the tensors, or you can think of as a matrix. Yeah, it's a vector and the matrix, and the next thing is, if you increase the dimension of that, it's gonna be the tensors. So everything in here we use the form of tensors. That's why we have tensor in TensorFlow. Flow means it stands for, or the name is coming from the computations flowing through the graph. That's why. So that's we have named the Google. They name it as a TensorFlow. And here I'm gonna study the explaining what. So here for the computational graph, there are three key data types that you should remember in TF. So the first thing is, remember, in order to use a NumPy, so you have to import it NumPy as a how do I say, MP things. It's same as, it's convention. You don't have to use a TF, but many people use a TF as a convention. So you're gonna import the TensorFlow as TF, and then we can use it. So in TF we have TF.constant, TF.variables, and TF.placeholders. There are different types in TensorFlow. So make sure you understand what it is and for each, and you have to know the difference here. And the first thing that I want to mention here is in TF variables is capitalized. I don't know why, but you have to make sure that it's capitalized. And constant is just constant. The value does not change in program. So if you have TF.constant like this, so probably it's like you define it and put it and assign it in A. And for B, you have TF.constant for, but here this is the shape, and this is the values, and this is, since this is the shape, probably B is equal to, so since this is the shape, that's another way that you can define TF.constant. And since we defined array, you can think of as array or vectors or TF.constant, we can do mathematical operations. And for example, here we have plus, and this one is multiplications. And suppose, let's say we do the plus operations and small a plus small b and store it in capital A, and I want to print it out. But if you do that, that's the answer for that. And we kind of expect, if you add these two, probably say we do summations and element wise, we get 5 and 6 and 7. That's some kind of the answer that we expect to see out of it. But here we don't know what it is, but the shape is, shape is, this is true, and D type means the data type is integer, things like that. So something is different from what you expected and weird, and I don't know why. I'm gonna explain why. And for very special thing is here in TensorFlow, the name is sessions here. To run any of 3 defined operations like TF.constant, variables, and placeholders, we need to create sessions first. The session will also allocate memories to store all the current value of variables. So here's the way that the TensorFlow is operating, and they have the sessions here. And for the training data set and features, whatever, and these are the 3 different types: placeholders, variables, and const. I did not explain what these things are yet, but say these are the data types. And I'm gonna do something here inside the sessions. And now we are ready to run. And once we run it, we will get the outputs. So the thing is, the difference, they say you have say you have in Python or NumPy, and you're gonna write it in line by line like this. And when you execute it, they're gonna read the first line, and you will execute it. And say this one is first, and second, third, fourth, things like that. So we execute it line by line. But the problem is, as you can see here, for deep learnings, generally it's going to require a lot of computations. So let's say we are here. So the computer is take a look at the first line and run it and execute it and move to the next line and just read it. And up at say we are at here, then we don't know what kind of the program line is in following. So the only information is we are up to here. So the thing is, when you're trying to have a lot of computations, and what the TensorFlow does is, you're not gonna do anything just but read entire line. So that means we're gonna put everything into the sessions. Once we read that, they're trying to figure it out what kind of memories they needed and what kind of operation they needed, trying to optimize trying to make the computations much efficient and easier. So once we figure it out, that they will just execute it. And they create these sessions and they run it. And once we're done, efficient way, they will print out the outputs. So let me explain what this means. Again, this is one of the examples here. I imported TensorFlow as TF and I define A and B using TF.constant. And here A is like that. And the B value is 4. And you think of the shape. Now we do summations. And if we did that, there's no the correct answers for that. But from here and say we're gonna create, say I'm gonna name the sets tf.sessions. I'm gonna open it, and in that inside that the sessions I'm gonna put everything and put A's, and I'm gonna run it. Then actually this at this moment they're gonna execute to compute the capitalized A. So now the answer is, as you can see here, if we do summations here, 5, 6, and 7. That's the how the TensorFlow is gonna compute it. And let's do the B. And as you can see, it's multiplications. And what kind of answer do you guys expect to see here? So this is A and B. I'm gonna do A multiplied by B. What will be the right answers for that? Any idea?
No answer.
Say that again.
That is impossible.
So what will be the values? I mean, these, let me, so as you can see, it's 4.
There is a problem of transpose, no?
And 12. Right? So what you can see that it's a product, but element wise. That's what the multiplication means in TensorFlow. Okay, don't be confused. It's different from like the matrix and the vector multiplication. So it's multiplications or product element wise. Okay, and for this and this A and B, I define it as tf.constant, and I'm gonna use the functions or the method in TF. So they have some multiply A and B, and this is another way that here with as, and we're gonna open the tf.sessions here, and I'm going to run it, and at the end this I'm going to print out, then I'm going to close the sessions here, and the output is, again, it's element wise. Okay. So this one is same as A, like that. Now I'm gonna move on to the second type of the variable. I mean, here is tf dot large B. This is a variable, and you can think of this one as a decision variables in optimizations. So you remember it's in let's say we have x of x minimize x. So this one is, suppose we're doing the gradient descent, then right. So what we did in gradient descent, we're gonna update it x each iteration. So that's why this is here tf dot variable is not a constant. It's supposed to be changed over some computations. And from here, this is how we update it, but this is the second step. First step is, at least at the initial stage, we have some values for the x. So we usually initialize x, right? So these are the two major requirements for decision variables, like here in this case is TF variable. So you just think of it, this one is when we need for the gradient descent. And for, let's say we have two variables, I define as TF variable and TF variables. And this is the type, this is floating numbers, and you don't have to worry about these things. And these are the values. I mean, this again, TF variable is not a constant, but this one is initial values. Initial values. So when you create it in some the x of 1 in your memory, so we define it as TF variables, then the computer and we kind of know that this one is gonna be, the value will be updated and changes over iterations. But at the very first time, I'm gonna reset or initialize it, that one with these. Okay, so I'm gonna do the plus operations. Again, since I didn't put everything into the sessions, so there's no answers at this moment. But at least we know that the shape is 2, and we know the data types. And again, next step is I'm going to TF sessions and create it, and I'm going to run it. But these are the steps that are required for TF variables because we need to initialize. So TF global under variables initializer means if we do that and if we do things, and inside this program, look for all the TF variables and initialize it at once. So here we initialize and we run it, and then we will get these values. So since at this moment, up to this point, there's no values, specific values are initialized, but once we have this one is executed, we know that x1 is x2, then we can run it again. We know that y is x1 plus x of 2. That's why we have these answers for that. Okay, that's the TF variables, that the way that I explain it. And third one and last one is the data type in TensorFlow is placeholder. I mean, the name is kind of weird. I mean, it's easy to understand. So it's some kind of place so that I can hold or put something on it. That's why it's placeholder. That's the name. So the TF placeholder. Let me see that. So let's suppose we have models here. In most supervised learnings or machine learnings, whatever, you have inputs and outputs. And these for supervised, I mean, these are input and output are given. Right? So whenever we train the models, we need some place, we need some memories or place to put it in input and outputs at the same time. Then read these values to train the models. Let's say we're gonna do the gradient descent, whatever. So for the machine learnings or for any kind of learning process or training process, especially for the supervised learnings, we need some place or memories for the inputs, and at the same time we need some space or memories and place for the outputs. That's how we, and for the placeholders, we're gonna put input and output. We will do iteration. So I think you can suppose or consider it the gradient descent. And the next step, we're gonna upload another inputs and another outputs to repeat the process. So that's why in Google, and they came up with placeholder type of memories or variables. And let's think about this. Let's say we open the TF sessions, and I'm gonna define it the placeholders. And here is the type, because this one I need know the type of the inputs and outputs, and also I need to know we have to know the shape of the structures. So this one is 2 by 2, right? So it's only shape. So X is in this case is kind of, so it's an empty room that you suppose. Okay. Now, so this is how we define the placeholders, and we know the types. And when you execute it, let's say in run, now we know that X is placeholders. Actually, at this moment, we put the real values inside the X. In that case, this is the syntax. So here, feed, we have to feed the values to X. That's why now by doing this, now X is gonna be like that. Okay. Feed underbar dict means feeding the data is here. The way that in the TensorFlow they decide to use dictionary type. So dict means dictionary. So we have key and values here. Okay. So the placeholders, let me explain it again. The placeholder is very special type of data because when you do supervised learning or whatever, when you do learning or training process, we need some place for the inputs and outputs at the same time. We're gonna feed that, but here in this case, it happened to be in the dictionary type. So in X, this is the placeholders, and this is the actual values that I'm going to feed into the placeholders. So suppose here, let me see. We have placeholders, and this the shape is 2. So it's like this is the placeholder. When you do some, I define it as a sum here, and I'm gonna feed dictionary values into A. That will be like that. B is like that, and I'm gonna compute it. Sum is A plus B, right? So it will be 4 and 6. There will be the outputs. So let me see that in that case, in the first examples here, and this is the X, right? And the second example is same as like that. So up to this point, do you guys have any questions?
No.
Okay. Now we're done with the defining or to explain for the 3 different types of is TF dot constant, TF dot variable, and placeholders. And let me do the tensor manipulations. And I think the first one or the easiest one is adding. Now we add that. So in that case, let me see here, since it's 1 and shape is like that, probably like this one, and this one will be like that. And I'm going to add, or you can do like that. It's pretty much the same. So the outputs will be like this. And I think it's for this case, let me see, the shape is like this one is, So this is x of 1, and x of 2 is gonna be 2, 2, 2, because this is the shape. And now do the additions, and this is how we can get it. Up to this point is no values defined, but we create sessions and we put everything inside the sessions and we run it, so then we can get the computation executed at this moment. Multiply, that's the second thing that we want to take a look at. Say we define it, the x of 1, x of 2 using the tf dot constant, and x of 1 is here. You can think of as actually this is you can think of as a 2 by 2 matrix, and x of 2, this one is this is not right. This one, make sure you know that this is the column vector. Okay. Now, I mean, I want you guys to see the difference. These are the different. Okay, and make sure, because in a lot of computations you will do matrix and the vector representations, and you do the kind of matrix and vector multiplications and the operations and manipulations. So the shape are so important. Make sure you check the shape every time. And now I want to multiply it. Here we have two different options. So let me ask, what would be gonna be the outputs that you expect for the first case and the second case? So what do you think? What do you guess? What do you think the answer for the first case?
Two, 4, and 9.
4,
12. 9, 12.
9, 12. Then what about this? What about here?
The same.
Same? Okay, let me see. So so actually this is the right answers for that. And this one is right for the second case. And from the right answers, what you can infer or guess is that here actually for it's MAT-MUL means matrix multiplication. It stands for. So actually this one is we do matrix 6. We do matrix multiplications like that. Okay, and over here, what we did, what the TensorFlow does, as you can see here, it's kind of do this kind of multiplications and this kind of multiplications. Okay, so it's a kind of element wise, but I mean, so I highly recommend whenever you do any multiplication operations, don't do this and do this, and do not use or
I have a
I don't
question.
recommend. Yeah, go ahead.
So by defining x1 and x2 like this, the software know them as matrix. They are data type or matrix, no, or arrays.
Let me. So, I mean, even for me, it's first time it's very confusing. So make sure that you get everything straight. But now my prime basic like recommendation is don't use this and use that. Everything you just think about every this is a matrix and the vectors and using just conventional matrix multiplications. So that's how I reduce the number of miscomputations. The chance of that I can get rid of it. All right. So next thing is another magnification that you're gonna use very often is reshape. As you can see from the name, it's gonna change the shape. Suppose we have x like that. So in tf.reshape, so this is the x, and again, what do you think? So I'm gonna reshape it, and what will be the x underbar? What will be the, what do you think the answer is gonna be? So the hint is this is the shape that I want. I mean the shape that I want. So it's a 4 by 2. So,
1, 2, 3. Oh no.
so I guess it will be like,
No, it's transpose. No.
oh sorry, so this is yeah, so it's a 4 and by 2, right? So again, it's like that. And the previous one that I made mistakes, if you write it this way, probably you will get, that's how we get. And the second case, these are pretty much the same except like this. And this one is very weird. How do you get -1 in the shape? It's weird again. But let me think about it. Since we know that this one have 8 elements on it, and this means this is not the, since we know the x is, we have 8 elements, and here we know that this is 2, and in this here is 2, obvious this is 4. Okay? So whenever you don't want to compute it, you don't have to think about the dimensions or shape, just put -1, because and the TensorFlow is gonna compute it automatically. So we're gonna fill the right numbers in that. So in this case, it will be like this. You will see.
And what if there are 7 numbers?
What is?
If there is 7 numbers for x, like 1, 2, 3, 4, 5,
I mean,
7, 6, 7.
You mean that what if the x is like that?
Yeah, 7 elements.
I don't know. Actually, what you can do is you have to write a code and to execute it to see that you have to see what the answer for that, right? Probably you guys want me to do it, or let me try. Yeah, I want to know. Let's see. Let's execute it. Let me see. I'm doing that. You guys are looking at the different screen that I have. What do you have in on you guys' screen?
We have the Jupyter notebook.
Okay, good. So I'm gonna actually run it. And A is get it. And these are the, let me try TF dot and placeholders, matrix multiplications, and let's try this one. So reshape that we can get it, get, and what we want to do. So this is the accent, and we get errors. So it does not have right the dimensions for that. Okay, so it's just smart enough that the TF can figure out the shape. Let me go back to here. So this is very convenient, and you're gonna see the -1 and very often in the Jupyter notebook later on. But to make sure that in this case it stands for 4. It's automatically calculated the shape. Now let's move on to say we're gonna use the TensorFlow as optimization solvers. Let me see. Basically, I want to for many optimization problems and gradient. This I think let me see. Gradient descent. I'm gonna I can actually implement the gradient descent method to solve the optimization problems. But in TensorFlow, it's the gradient descent method is embedded, so I want to use that. And with this example for that, this is the decision variables omegas, and this is the objective functions for that. And we know that there's no constraint on omega, so it's an unconstrained optimization problems, and this is convex. And we know that the solution is 4 because I mean this is too obvious. And I mean this is the very trivial examples, but let me use a TensorFlow to implement and to get the optimal solutions. And the first thing is here omegas. I mean, omega is a decision variable, so the value will be updated in the gradient descent in every iteration. So define it as a TF dot variable. And for this one is we have to initialize. So initial value I just set zeros. It's doesn't have to be zeros, but here when you initialize it will initialize the value of omega as zeros, and these are the type. This is float. And the code, I mean, here the objective function is here. And that's how I implement it. Now, I mean, here I use a cost, and this will be the cost functions. To do that, I will just here skip this process and say we have TF dot variables in our program. I need to initialize it and open the sessions and initialize, and I want to compute it, the omegas. And let me here want to minimize the cost. I want to minimize here. Remember for the gradient descent, and say this is objective functions and like that. So this is alpha is the step size. This means that TF dot train, there's a function, is a gradient descent optimizer. This one is same as alpha. I'm using LR, which stands for learning rate. Okay. And if I printed this, I initialized it, and what kind of the values that you guys here? It's 0, because I didn't execute this OPTM yet. So if I print it out and run it omegas, and you will get the initial values. Now here I run opt-m and I print it out. So the first value is here. That means, so let's say I was here, and if compute the slope or gradient, and we do the gradient descent updated, so probably I will move this way. So the first, using this kind of step size was the like that. And if I run it again, it will move further this way. So that's how we, do gradient descent using TensorFlow. And this is for loop. I'm gonna run these things 100 times. And at the end, if I print it out, as you can see, the value is almost, as you can see, as you expected, right? So it's getting closer to the true solution. That's how I use a gradient descent implemented in the syntax of TensorFlow. Right? Any questions on this slide? So again, to figure out what kind of decision variables that you have and define objective functions and define what kind of the optimization, iterative optimization scheme that you're going to use. And since we have this is TF variables, and initialize it and run it. And if you need to repeat the process, you can use like a for statement, whatever, to run it, to repeat that iteration process. Now I'm going to do machine learning, like the method or the algorithm that we learn it using the TensorFlows. So first thing is regressions, and I don't have to go through the regression again. And so this is the problems and the statement that I want to compute this guy. And this is the regression with TensorFlow. This one. So again, the running rate alpha is I define it, and this is the number of iterations that I define. You don't have to do the same, but I believe this is it's large enough. And for how many data points here? Let me see, 5. We have 13 data points, and 13 mean like x1, how do I say, y of 1, x2, y2, x13, y13. And again, I'm gonna use placeholders to store x and y, and m is equal to 13. So x is the space like this, and y is like, this is empty space. Empty space. Gonna reserve the empty space later on when you train the models. I'm going to feed x and y into these placeholders. I preserve the space for, and the omega is here. This one will be y is omega x plus b, right? And the omega is b is just constant values, and TF variables, and this one is initial. I set initial values zeros and initial values at 0. And I need define the objective functions or loss to optimize or to take the derivatives of that. And we know omega and x, we knew matrix multiplications. And here, let me see, x is the shape is like that. the omega is here. I mean, just 1. If we're doing matrix multiplications, we will do, so this one will be another 13 by 1 matrix. And now after this, we'll do additions for the B is like, again, yes, and now we do element wise, we'll do additions. So there will be another 13 by 1 matrix as a y underbar, predict. So this is same as y hat, but the shape is the column vectors. And in the regression problems, the objective function is y hat ith and y the true values and square it, and I do for entire data set, or and divide by 13. So here I use square tf dot square, I do square it, and these are the vectors. And so this one is spread is, and this is and minus and the true values, and you will get another 13 by 1 column vectors, and I will do squares, so it's element wise squared. Then since I need to compute this, so this one is here tf dot reduce means. That means I will do this kind of operations. Actually take the average values. So I will get single values out of it. So that's the loss. Same as this is f of omegas. Now, next step is to obvious that I define the loss functions, minimize it using the gradient descent optimizers with this kind of running rate. And I open the sessions and I initialize it. And I'm going to run or repeat iterations with each epoch. This is how many? Like 10,000 times. I'm gonna run it. When you run it in X and Y, these are the placeholders in X and Y, and I'm going to put the train X and train Y and use feed dictionary types and execute it to optimize it. So once we done this part, we compute it to finalize omega and B. This will be here the values, and I plotted this. This is the how we compute it. The linear regression problem using the gradient descent, but I implemented in TensorFlow. And I guess, I mean, probably this part is not that obvious. So, and I want you guys to think about it. And here is reduced mean is here, this is vector, and this is scalar values. Any question here? Or everybody's happy? Good.
It's
Yes.
good. Yeah.
Let me continue. This one is pretty much the same. The only difference is that, I mean, the contents here is the same. The only difference I use here with and as, and you don't have to worry about them much. I mean, those are pretty much the same. And let's move on to logistic regression, and I'm gonna use the gradient descent method to get the solutions from the logistic regressions. Suppose we have these kind of the binary classification problems, and as you can see, I want to find out these linear classifier and as a boundaries and using the logistic regressions. And here we know it's in x of 1, x of 2. The boundaries g of x is zeros and x1, omega 1, x1 plus omega 2, x2 plus omega naught, or omega transpose x, or x transpose omega is equal to zeros. I mean, if you guys remember from the previous lectures, and those are the notations that I used to represent these. And let me see. And I hope you guys remember this. This is kind of artificial factors too. So I have 3 different omegas, and these are the featured the inputs. Okay, and here it's actually it's a 2D problems. It looks like, but 3D problems. I tweaked it, and I transpose each data point, so I will get like this. And these m is number of data points. For the corresponding, these are the labels. And for the logistic regressions, I will get either zeros or 1, things like that. All right, that's the problem settings and the setting for the data set that I prepared. And again, it's running rate, number of iterations. And now we have to think about the placeholders for input and outputs. And m is again is number of data, and here we do and these we know that like this one is already transposed it. So now here, remember this one was the equations, but in these notations, since x is transposed it will be like that. And the omega is TF dot variables, and with like that. And I'm initialize, it doesn't have to be, but actually you can generate it using the random generators, but I just, to make the problem simpler, I just initialize with zeros. Okay, good. And let me, this point. And if you remember it, for logistic regressions, we have to define it in cross entropy, or remember it's the sigmoid functions or logistic functions, and we take the log on it. So these are the objective functions or loss functions. And this is not a loss function. Actually, we have to maximize this. That's the first thing. And let me see. For x and omegas, we will do this kind of computations. And these will be m by 1, and which is y, which is x matrix multiplication by omega. I mean, I didn't use transposer because the capital X is already transposed it. Now I'm going to take the sigmoid functions. So here it's a sigmoid x omega. Now I'm going to define the loss functions. And here it's y values. And this one is sigmoid x omega, which is same as y predict. And just take the tf dot log. Then we have 1 minus y, and tf log 1 minus y predict. And this one is positive values, and I'm trying to maximize it. And I put minus sign on it, and I'm going to minimize it. those two are equivalent, right? I use minus signs to, instead of maximize the objective functions, I'm trying to keep the convention that I want to minimize any objective functions or loss. And up to this point, the loss is, again, it's a column vectors, and I'm use tf.reduce means to get the scalar values on that. And this will be the loss values I'm going to minimize using gradient descent optimizer. Right? And here are pretty much the same. I use a global variable, initialize it. I'm going to repeat it in each apple with until up to number of iterations. And I'm gonna run it and put everything into sessions and run it with, for each iterations, I'm gonna feed. So these are the placeholders. I'm going to put, actually these are true, the training data set into X, in the placeholder of capital X and placeholders of Y. I'm going to put it and run the optimizations. And at the end, probably at these iterations, we're gonna do gradient descent. So we're gonna update the omega each time. At the end, we compute the omegas, and there will be omega half. There will be this. Okay. So basically, the key thing is you have to use a gradient descent. You have to know how we can define the objective functions. And since we have many data set, I'm going to put it in the either matrix or column vector form. So when you compute it, be careful on the shape of or dimension of matrix, or either matrix or vectors. So that's, you have to keep eye on it. And pretty much here, this part is pretty much the same. Just gradient, you define the optimizers and do it gradient descent iterations. And each iterations, and we feed it the either train the X input and outputs into the placeholders and run it. Okay, so this is gonna be the slide for today. And the logistic regression we're going to use a lot. So whenever we have to do this, and it's kind of this. So in TensorFlow, they decide to embed these functions. So for binary classification problems in TF.NN, it means neural net. We have sigmoid, cross entropy with logit. That's embedded functions. So you don't have to worry about it for the logistic regression. For multi-class classification problems, if you remember it, say you don't have to understand, but I mentioned that just remember the name is softmax. So here the only difference is binary class is going to be the sigmoid. For the multi-class classification problems, it's softmax. So softmax cross entropy with logit. So using that, up to we define the placeholders and TF variables for the omegas. And here we do matrix multiplications like that. And since we have sigmoid, and you don't have to worry about, and these are the predict values, I'm going to put it here, and these are the true values. So using that, and this is the column vectors, and I'm going to use tf.reduce means to get the scalar values, and these are the same as previous one. Okay, and you will get the same omegas. For multi-class classification problems, I mean, the only thing is instead of sigmoid here, you use softmax. That's it. Okay, let me